Hi everyone, we are still on dispersion. We gave a brief introduction of what dispersion is. Now we are going to use that information we've studied to solve a problem here. The problem says the weights W in kilogram, that they are measured in kilogram, of the items of a baggage checked in on a flight from London to New York are shown on the table. This is the table here. Weight of baggage, the flight was departing from London going to New York. So the baggages of the customers are these ones here. Those that weigh between 0 and 10 kilogram, it's 22 of them, 22 bags. Those that weigh between 10 and 14 kilogram, 75 bags. Those that weigh between 14 and 18 kilogram, 102, and 18 to 25 kilogram, 53 bags. Now we are asked to find the lower quartile and as well as the upper quartile, and then the interquartile range of this data set. So where do we start when we are given a problem like this? It's almost always certain that in statistics, when you are given these kinds of tables, you can't just jump straight away into solving the problem without adding another table to this one, another column to this table you are given. It depends to the kind of information you are provided with, then you know which column to add. For this one here, we know the number of items here: 22, 75, 102, and 53. So the column we need to add here is the column of cumulative frequencies, because these are frequencies. These numbers you see on the right hand side here are frequencies, simply telling you the number of bags between 0 to 10 kilogram. We have 22 of them. You can't just write number 1, 0 to 10, number 2, 0 to 10 kilogram, 3, 0 to 5 kilogram. That's what it means. In between here, you can have now from 0, that is, there could be a baggage here that is 5 kilogram, but it all falls under this range. So in that sense, we need a third column here called cumulative frequencies. That is summing up these frequencies. Cumulative frequencies. So we add this one. Correct. Now we have this third column here. Frequency here, this one here is 22, it doesn't change. If you now add 22 to 75, you get in 97. If you add 97 to 102, 102 plus 97, you get 199. If you get 199, you add 153. This is 12. This is 12, 31, 10, 15, 5, 2, 252. So this one here is 252. Sometimes this is one thing, you write something different. 252. That is a cumulative frequency. So our first question says, find the lower quartile. Remember our introduction before, when they ask you to find the lower quartile from a data set, lower quartile, which is Q1, this is N all over 4, right? N all over 4, that is your elements in your data set divided by 4, will give you the lower quartile, will give you the position of the lower quartile. This one gives you position. This formula, it gives you position, not the actual number itself, right? It will give you the position of where the quartile, the lower quartile, lies, not the lower quartile itself. So if you have this data set now, you divide it by 4, it will give you the position of where it lies, where the lower quartile lies. But then you need to calculate what that lower quartile is. And then another method we're going to apply. So now here you can see that N is 252 here, cumulative frequencies. How many bags appear? It's 252 bags we have. So this is going to give us 152 divided by 4. 152 divided by 4. 4 here. 4 is 3. 4 into, no, it's 252, sorry, 252. Oh my God. Divided by 4. So 4 times 6, 24. Plus 4 into 12 is 3. So it's 63. Yeah? And where does 63 fall? 63. 63 falls in this column here. Yeah? So our lower quartile falls in this column. 10 to 14 kilogram. The bags that weigh between 10 to 14 kilogram. That is where the lower quartile falls. These numbers I just said, this is not the answer to this question. The lower quartile, what you found here is just a position. This is telling you that your lower quartile falls within this range. We have to find it within this range. Now we are going to find the actual value of the lower quartile from this range. It falls here. It's not in this category, 0 to 10. It's not in this category, 14 to 18 or 18 to 25. It is here, 10 to 18, where our lower quartile falls. We are going to find it now. Finding that number or that value, there are some methods, different methods people use. Some use interpolation, but interpolation is another topic. So bringing it here, just using it, it will not help. So it will not help people. People who have not done interpolation before, just coming to apply it here and give an answer, it will not help. So we'll do something like what we call ratios and proportions. Those ones, you do them even in primary school. Ratio, which compares two functions. Proportion, which says the two proportions are equal, the two functions are equal, or the two sets are equal. That is proportion. So what we are going to do here, you have this line. Let's say you have this line now. And up here, we are going to represent our weights. Bottom, we are going to represent our frequencies. That is cumulative frequencies. Here are our weights. Mind you, we'll be looking now at these two columns. This column and this column. For now, ignore this, because we're using cumulative frequencies now. Yeah? And we are looking at weights. So we know the weights we are looking at the quartile we want to find, it falls between 10 and 14. So if this is here, 14 is here, the quartile, we say the quartile now, Q1 is here, and we know it's between 10 to 14. So if we say here is A1 and this is B1. As I told you, we are going to do ratios and proportions. Then, now for the frequency side, as you will put at the bottom, we know the frequency is from up to 97. Yeah? So we have from here to here again. A2, and then from here to here is B2. Clear? And we are looking at frequencies. So the frequencies we are looking at, we know they start from 22 here to 97. It's within that range. It starts from 22 to 97. The quartile, lower quartile we are looking for, it starts from this range we have, because you see this less than or greater than signs. This is something else I don't want to go into. This is for group data sets. When you have this group data set, finding an answer to any question here is not like you just go in and put formula, you get it. It's not like that. Because of this less than equal to signs, they're affecting what we are doing here. Right? We can't just say the answer, oh, get it from here. Because you see 10 is here, 10 is here as well. So that answer we are finding could be in this category, it could also be in this category. You are not certain, 100% certain. That's why we do something like this. Yeah? 0 to 10, 10 to 14. So there is 10 here, maximum 10 here, here minimum 10. So it could be on this category, it could also be on this category. So when you're solving problems like this, that's why you see this kind of maybe like complex solution, but it is not. Yeah? So you have that one there. And you know, the 63, this 63, we found it was here. This was here, 1 n all over 4. Yeah? So now we have this ratio and proportion. What does it tell us? What can we do with it? You see from here, we say from here to here A1, and from here to here is B1. So you know that A1 all over B1, that ratio, now we're using proportion, must be equal to A2 all over B2. Agree? We are using the same line. We just divide it into categories in ratio form. Ratios, they don't lie. Because they don't show actual answers. They show a relation. You see? So I need to erase some things here so that I can get space. Yeah? So let me come here and take this off. Let me take this whole thing off. The board is small, sorry about that. So this is telling us that this is 10 to 14. We are now having A1, which is Q1 minus 10, Q1 minus 10, because this is 10. So Q1 minus 10 all over B, which is 14 minus 10, 14 minus 10. This is A1 all over B1 equals to A2 all over B2. It's what we are just doing there. A1, if you want to find the value of A1, you subtract this from this. Is if Q1 minus 10, that is A1, and B1 is 14 minus this. So when it comes down here again, A2, which is 63 minus 22, 63 minus 22 all over B2, which is 97 minus 22. 97 minus 22. Right? So you now have here Q1 minus 10 all over 4 is equals to 63 minus 22. This is 1, this is 41, I guess. 41 all over, this is 5, 75. Yeah? 97 minus 22, 5, 75, yes. Okay? So this is now a simple equation to solve. We want to find Q1. So what do? We will now have Q1 minus 10 equals to 4 times 41 all over 75. 75, that is Q1. That is Q1 minus 10 equals to 4 times 41 all over 75. If you further simplify this will give you Q1 equals 4 times 41. 4 times 4, 16. This is 164 all over 75 plus 10. This minus 10 now becomes a plus 10. Yeah? So let's simplify. Let's use the calculator there. Let us go with ourselves. 164 divided by 75. You get 2.18666 plus 10. You get 12.18666. Your answer is 12.186 repeats. So now when you get here, I'll round up to 1 decimal place anyway. So this will give you 12.2. 12.2. So your Q1, the lower quartile range is 12.2. 12.2, yeah? So this is 12.2. That's what you get. So which means our assumption was right. It falls between here. 10.2 kilogram. It falls between here, between 10 and 14. So the next question says, find the upper quartile. It's just exactly the same thing. Just the numbers change. But exactly the same process. Yeah? So I will erase this one and then solve. But the same process anyway. So now let's find the upper quartile range, which is Q3. They hardly ask you to find Q2 because Q2 is the median. That is half of what the data set. Everybody knows how to divide by 2. So mostly they're interested in the lower quartile, upper quartile, and then the interquartile range. So now we are finding the upper quartile range, which is Q3. I know Q3 is 3/4 of the data set, which is 75% of the data set. Yeah, our n here is 252, so which is 3 all over 4 times 252. This again, calculator. Oh man. So 3 divided by 4 times 252, you get 189. 189. So again, we do what we did previously. Draw your line, you put the weights, top, and the frequencies, cumulative frequencies, bottom. And now you know your Q3, let's say it is here, which is, let me put it here, Q3, which is 189. And 189. So Q3, 189. So it is around here in this category, 14 to 18. 14 to 18. So for the weight, they start from 14 to 18 for the weight. Yeah? But from here to here, your Q3 here, again, we'll say A1, and here, again, we'll say B1. Right? On the frequency side, we know it starts from, what did they say? 189. 189 is here. So from 97 to 199. 97 to 199. The frequency lies. So your A2 and B2. I hope you understand how these figures have been represented on the line. 102 to 199. 102 to 199, 97 to 1. So sorry. It's false here. It's 102. We said here. So it's 102 to 199. Sorry. Yeah? We said it's 189. 189. This is 199. Yeah? So 189 is in this category here. So now we have this representation here, which we can solve just the same way as we solved the previous question, applying ratios. You have A1 all over B1 must be equal to A2 all over B2. So in this case, A1 here, which is 189 minus, which is Q3, sorry, Q3 minus 14, Q3 minus 14 all over B1. B1 is 18 minus 14. 18 minus 14 must be equal to A2. A2 is 189. Help me. Go and do toothbrush. A2, which is 189 minus 102 all over 189 minus 102 all over 199 minus 102. Yeah? So this is what you have. So then you have here, we simplify, just simplification now. This is Q3 minus 14 all over 18 minus 4 is 4. And this is 189, 102, you get 7, 0, 102. 102, so 7, 8, 87 divided by, this is 7, 9, 97. 87 divided by 97. So once Q3, so Q3 here, which is equals to, you will now have 4 times 87 divided by 97 plus 14 is minus here, now will be plus 14. So this is your answer for Q3. Let's simplify. (87) divided by 97 times 4. So you get 3 point, was it 14? Yeah. 3.587 plus 14, that gives you 17.587. 17.587. Let me see. This is 14 to 18. Yeah. So that's what you get. So if you round it up, this one here, to 1 decimal place, you get 17.6. 17.6. So this is the upper quartile range, 17.6. 17.6. Now you are asked to find the interquartile range, which is very easy to calculate. The interquartile range, IQR, this is equals to Q3 minus Q1. So it's simply 17.6 minus 12.2, which is equals to 5.4. So this ends the question. Thank you very much for watching. You can subscribe, you can like, and you can also send to your mates. Share with your mates. Thank you for watching. Bye bye.